Hello, fellow humans. The following is a conversation with Dr. Michael Frank, chair of the Department of Psychology at Stanford and director of the Language and Cognition Lab, known for his groundbreaking work in early language learning and open science. In this episode, we explore how children acquire language, not through memorization, but through meaningful social interaction. And Dr. Frank shares insights from massive data sets like WordBank and tools like the MacArthur-based CDI, giving us a clearer picture of how vocabulary develops across cultures, contexts, and individual children. We'll discuss why there's so much variability in early language development and why that variation is surprisingly consistent around the world. You'll hear how some children build their language through nouns, others through expressive phases, and how understanding these patterns can directly inform early intervention strategies. So, what lies beyond the words we speak? Tune in and find out. All right. Hey, everyone. Welcome to Beyond Words, conversations on language, music, and mind in collaboration with speechtherapypd.com. I'm your host, Garrett Oyama. I'm a musician, a practicing SLP, and a PhD student with an interest in all things language, music, and cognition. And I'm so excited that we have the real force of nature here today, Dr. Michael Frank. Dr. Michael C. Frank is the Benjamin Scott Crocker Professor of Human Biology at Stanford, where he directs the Language and Cognition Lab and the Symbolic Systems Program. His work asks how children learn language and how social interaction shapes learning, combining experiments, computational models, and large open data sets such as WordBank and MetaLab. He founded the Many Babies Consortium and was elected to the American Academy of Arts and Sciences in 2024. Before we get started, just a couple of items to mention. Most of these upcoming podcasts, including today's, will include an accompanying course on speech therapy PD that's available for 0.1 ASHA CEUs. Just a couple of disclosures. We each get some compensation from Speech Therapy PD, and we may discuss some of the open science tools and repositories that Dr. Frank has been involved with, such as WordBank. So without further ado, Dr. Frank, welcome to Beyond Words. How are you doing?
Great. Thanks for having me.
It's really an honor. I always ask the guests a little bit about their origin story and was just wondering how you got interested in this field of language.
Yeah, I think I've always been interested in language as a tool for narrative and as a tool for shaping our identities. And during college, I got involved in doing psychology research on differences between languages and how that might affect our cognition. There's a researcher named Lara Boroditsky who was working on that topic, and her work really made a big impression on me, and she brought me into her research group and got me excited about that topic, that the idea that we could use empirical methods from psychology to study big philosophical questions about language and how it makes us who we are. And from there, I got excited about how language starts with kids. And another mentor introduced me to language acquisition research. And once I got there, I was really hooked by the idea of studying learning and studying the genesis of language. And that really felt like it tapped into all these big questions about what makes us human and how we relate to one another and everything.
That's really cool. I also found out recently, we just had Dr. Ted Gibson on last week, and I was wondering how you got connected with him. It seems like his research in a way is different from Dr. Boroditsky's research because he sort of separates thinking from language, or at least that's one of the things that we mentioned.
Yeah. So Ted was my graduate advisor, and he was an amazing advisor. And one of the things that made him amazing was he was just so open-minded about letting me get involved in whatever I was excited about. So I was applying to graduate schools, and I wasn't sure if I fit at the MIT program. There weren't really a lot of people doing developmental work. And I remember this call with him where I kind of made the pitch that my interests intersected with his. And he said, okay, let's give it a try. And then throughout graduate school, he'd say, well, I don't know anything about this, but tell me what you're working on and I'll try to help. And I thought that was just such a wonderful attitude for an advisor to have. He was not in it for himself. He wasn't trying to further his own agenda. He didn't have a horse in the race. He was just trying to help me learn how to do research. And that was just, a fabulous gift to have that as an advisor.
That's so cool. Yeah, I really got that sense from him. He seemed like a super open-minded and just really interesting guy. Yeah, so I mean, you've covered so much ground in your research, and I'd like to start maybe with the early word learning stuff, because I think that is helpful for SLPs. And I also thought that maybe it might be helpful practically to start by discussing something that's familiar to clinicians, which is the MacArthur-Bates CDI. Can you talk a little bit about WordBank and maybe how you got that started and where the idea for this came from?
Absolutely. So I've always been inspired by the twin examples really in child language research of the child language data exchange system, and the CDI. There are these two foundational tools for the field where there were people and communities around them that were really open and really focused on disseminating kind of all the knowledge and all the data that they had gathered in an open science kind of ethos. And so I thought that was incredibly exciting as I was getting started. And in my PhD, what I was trying to do was make computational models. At that time, these were very small pre-neural network models or pre-new AI models. These were kind of statistical models that were trying to explain little aspects of word learning or word segmentation. And I kept running into this fundamental barrier, which is I didn't have enough data to fit the models or to evaluate the models. Um, and so that's how I ended up turning to first the Childis and then to the CDI as tools for like just accessing a lot of data about kids, just so that you could anchor these complex computational artifacts in the reality of what development actually looked like. And so the CDI especially appealed to me because it gave you such a granular view of the words that the child knew. So I started getting involved with the CDI board, which is a wonderful group of folks who started out with Liz Bates and others originating the tool and now have curated it and built up this international community of folks creating by the way, I should say CDIs are parent report surveys. So they're creating these parent report surveys about kids' early language and disseminating them, making sure that they adhere to particular standards, making sure that there's kind of a community of people using them and understanding how they best should be used and so forth. And the CDI board was really interested in the opportunity that was posed by having all these different languages around the world where SLPs and developmental psychologists and educators had all made CDIs for different languages and had collected data on them. So they would say things like there are dozens of languages or even more than 100 languages where there are CDI adaptations. And I started thinking, well, could we get all of those data back and put them in a repository so that everybody could access them and so that we could really fit our computational models and also just describe and understand language development across all of these different languages. And so that was the genesis of the WordBank idea was, could we catalyze this community that already existed by creating a repository where all the data were stored together?
That's so cool. And it seems like you're one of the first people to bring these really big data sets to bear on the questions of language learning. And just some little connective tissue. We met at one of the Beck talks at UCLA, and there's some just amazing things that come from looking at these large amounts of data. And I remember you mentioning that there's all this variability across languages, but the same types of variability. So, at first your thought was that English, because it's like we have different types of environments that we grow up in, that word learning is probably pretty variable. But when you got to get this big picture and look at a bunch of different languages, it seemed that variability existed across languages.
Yeah, yeah, absolutely. I'm so glad you brought that up because it's one of my favorite things that we found with the WordBank data. Before I get there, I just want to say I really want to acknowledge how much work there was in sort of trying to use big data approaches in child language, like by folks like Brian McWhinney and by Liz Bates and many others, some of the pioneers working with Lena technologies as well. So our work, we try to take things to a kind of a high level in terms of the accessibility of the data, and we're working on that. But that builds on the shoulders of a lot of people who in this community who have sort of set up the values and the systems that allow us to exchange data freely.
Got it. Yeah, you've definitely taken it to the next level, though, with a lot of your, yeah.
Yeah. Anybody who kind of goes into a classroom full of 2-year-olds or assesses 2-year-olds in their practice, or even 1.5-year-olds, you just know how much variability there is in the kids you see. I mean, it's the first thing you notice. There's no garden variety 2-year-old with respect to language. Like you'll walk in and some kids are talking in full sentences. They are saying stuff to you that feels very adult-like. They're engaging in complex narrative play. They're very comfortable with complex sentence structures. And there are other kids who really have very few words. And some of those kids will require clinical intervention, but some of them are just a little slow. They're late talkers, but they will catch up. They're late bloomers in the terminology that some folks use. Uh, so that variability is just, part and parcel of working with kids, but it's hard to know without larger data sets what the quantitative nature of that variability is. And so in the original CDI monograph, back in 1994, when the folks developed the CDI, they titled it variability in children's early language, right? They knew that they were measuring variation, um, but they only had a single sample, large sample, but still just a US sample. And so it was hard to tell uh, what to compare that variation to. They just saw that there was a lot of variation. What we were able to do with WordBank is we look at the variability of kids' language growth trajectories, their vocabulary sizes, and we look at that variability within the US, and then we look at it in China, and we look at it in kids learning French in France, and we look at it in 20 odd samples around the world. And the really striking thing was that as closely as we could measure, the degree of variation is really very similar. And what I think about that similarity is it's like a really suspicious coincidence because it means that the variation in the US isn't just due to the fact that we have socioeconomic stratification or kids with multilingual backgrounds or whatever. Like the Beijing Mandarin sample that we looked at, that's all first kids in very, very similar, monolingual in similar childcare situations for the most part. So the variation there, if it were socio-demographic purely, we'd expect it to be compressed, and it's not. And that's, you can think of some other samples in our database where the variation might be expected to be even larger if it was purely socio-demographic. But again, we don't think it is. We think that's in some ways intrinsic to the learning process, potentially because especially spoken language loads on so many different systems, right? We've got cognitive development, we've got speech motor articulation, we've got the input-driven learning of individual vocabulary items and the opportunities in the home. We've got, the richness and diversity of kids' experience driving the size of vocabulary. Like there's lots of different things that are going in there that serve to kind of create that distribution. Some of those are intrinsic to the kid, maybe learning variability or speech motor issues or any of these drivers of language delay or language acceleration for that matter. And some of them are extrinsic and have more to do with the family and the environment and so forth.
Yeah, this is making me think of something else that you had said in a talk, which was that when kids are very young, like the motor, the other aspects of motor development, like walking, are coupled to speech development, like babbling. And at some point, they decouple, like the motor development and language kind of decouple. And this kind of result makes me think of the fact that the 0 to 6 months, where kids are learning to babble and they're like developing aspects of motor control, their speech system is like relatively robust to differences, probably because there's less factors like impinging on this sort of development. And then as the child is, developing these like more complex language systems, have so many more things that they're kind of riding on, that maybe creates this variability. Is that maybe what this suggests?
Yeah, I think that's possible. I mean, so the observation there that you're describing is this idea of differentiation, right? And this is pretty well attested with school age kids that when you look at adults and you look at the structure of variation in adults' cognition and they can be variable in a lot of different ways. Some people are, maybe better at verbal stuff, and some other people are better at, visuospatial stuff and executive function and so forth. These things pull apart in cognition. And the differentiation finding is that variability kind of squashes down. You see that there's still some dimensions, but it's lower dimensional for younger kids. What we've done in our research is look at data from infants, and these are caregiver reports. So there's a bit, there's that, which is there's some reporting bias and so forth. But what we find is that babies are kind of fast babies or slow babies. They, roughly speaking, everything groups together. That's the finding you were describing. But when you start to look at toddlers, you can get a kid who's really good at climbing stairs, but is not so good at talking, or vice versa. And so that's that variation decoupling. And your speculation, I think, is really interesting. I'm not sure. It's possible that that's because there's not as many kind of causal chains that have to happen for you to be good as a baby. The one thing that makes me question that, and this is just a question for me, is that you can see predictive relationships between babbling specifically and language production as a toddler. So
Mm,
babies that
right.
babble less and have later and less canonical babble do go on to acquire vocabulary slower.
Mm,
The same is true
mm.
for pointing and joint attention a little bit later in the first year. So there are these real reliable predictors of language development in the first year in both speech production and in, or babbling, whatever you call that, and in social attention and social communication and gesture.
Yeah, absolutely. I'm a really big fan of Tomasello's work and like the triadic engagement and that sort of ability to point and show things is such seems like such an important aspect of language development. And actually, there's something in uh, the WordBank insights that you got from WordBank that really stood out to me was that the earliest words of kids were not really basic needs words. They're like, people's names and these more like socially focused words. I thought that was such a cool finding. Is that what you thought going into it, or was that something surprising?
I sort of hesitate to admit it, but I didn't have a good sense. I knew my kids' first words, but I didn't have a good sense of what first words would look like at scale, and especially not across cultures. And then I found this beautiful work that actually my collaborator Virginia Marchman was involved in, a CDI board and team member. But this was led by Twyla Tardif, where she looked at first words across a couple of different cultures in East Asia and the US and found that they were similar. And we extended that by looking at first words across all of the different samples that we had, um, and found, yeah, that they were remarkably similar, that they're words for games and routines. I mean, that's the category, but it's things like uh-oh or hi, or bye. Let's see, bath sometimes makes it on the list. Then no, which is a remarkably abstract word to be a first word. And then, yeah, names of people, dogs and small animals and ball, and these sorts of things also make it on the list. And yeah, I think you're exactly right. When you think about what are those words, there's like stuff that's fun to share with people, not feed me, change my diaper, right? The
Yeah.
basic needs, they're not far behind, but they're, for almost no kids, is that the first word? It's much, much more frequent that it's something they want to share and want to use language to communicate about. And then the basic needs usually get taken care of as part and parcel of being a baby.
Yeah, that's so interesting. One thing that we talk a lot about SLPs is communication functions, and it's something that we use as a strategy for helping kids learn language and helping parents understand how to engineer situations to make language happen. And one thing that I've noticed a lot is, and this is especially in autism, is that it's really hard to create the need for those, socially, those words just about showing something because there's more of like this intrinsic motivation to socialize. And, the other ones like requesting and rejecting and things like that are a bit easier to engineer. Like, you could set up a situation where they want a snack and they want a snack, but you have it all, and then they have to request before you give it to them. But those ones where it's like the going back to the Tomasello stuff where it's like the child holds up an object like ostension. It's just like, hey, look at this. This is cool. It's really hard to engineer those situations. Yeah, so just kind of an interesting thought in speech therapy work that we tend to have to go towards the requesting and the basic wants and needs stuff as first words for kids who don't naturally want to share, if that makes sense.
Yeah, yeah, absolutely. A couple of years ago, actually more than a couple now, I sat in on a parent tutorial for pivotal response therapy, right, which is an autism therapy that focuses on training parents to provide language intervention, basically, primarily language, a little bit of behavioral intervention based on a lot of those principles. And it was really striking to me how the instructor for that therapy session was trying to teach parents what constitutes an opportunity to slip in a communicative need. Oh, we're playing a game of this type. How can I slip in like now you need to show me this in order for the game to proceed. to really yoke things to the child's own interest and motivation. And it struck me, how brilliant therapists can be in creating games, creating opportunities in simple play to really scaffold in that way. Treating the child's or taking the child where they are in terms of motivation and interest and treating that as the driver of a communicative opportunity and through that scaffolding. So that was really exciting for me to see. And in my time seeing some therapists, including my son's speech therapist, I've that just reinforced the insight that a really good game is a really important step towards having a therapeutic tool that works. It's just engaging the child's attention and motivation to get them to practice the skill, whether it's an articulatory skill or a communicative skill.
Totally. And yeah, those underlying skills of attention and joint attention are all like, it's once you look into this stuff, you just realize that that's like the fertile soil for everything, like almost like all learning like comes out of that. Um, yeah, yeah, pivotal response therapy is really cool. I haven't done any official training in it, but I like know sort of the basic concept. Yeah, I can't remember if we were having a conversation about this or if it was somebody else around that same time that you were doing the Beck talk, but there was a conversation around like people focused versus object focused. Like certain kids tend towards being one or the other. Was that something that we were talking about, or maybe not?
Yeah, I'm not sure if we were talking about it, but it's certainly something that's been a big focus of interest in the autism literature. Um, yeah, I think as always, it's there's this idea that we can take a decontextualized lab task and identify some trait of the person that's like really critical to to every piece of them. And then the pushback is always, well, a lot of behavior is situational and contextual, and maybe the trait is modified. So I think
Right.
one of the big challenges of that, the translating that literature into therapeutics, is it like feels like there's this trait, but then it's only sometimes in evidence in the kid. So
Mm.
I'm part of a consortium called RISE, which has been trying to do early infant screening and is starting really at the very beginning by just building up a battery of tasks for infants that show reliable and robust effects that allow us to measure sort of general cognitive tendencies. And we are able to replicate that social or non-social preference. Like that is really a robust thing that we can see in kids. Um, how it plays out, in communication and in kids' interactional preferences when, in
Mhm.
real world, I think that's one of the big challenges. It's like, you know, when you see a child who's older, who's not just looking at a screen with a geometric mobile and a face, but when they're actually trying to interact in the clinic, like you're seeing the end point of a lot of learning based on that attention, as opposed to just the attention itself. So I'm just
Yeah.
responding with this little bit of caution about these lab tasks that are, powerful and interesting tools, but kind of just a starting point that doesn't tell you everything about the way the kid will interact in a real setting.
Oh, sure. Yeah. 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 Definitely in clinical practice, it's like everything changes. Like every kid is different, and like obviously there are similarities, but yeah, it's striking how much context plays a role. How like really there's so many differences in between kids. It's amazing. Yeah, I'm just wondering if there's anything else that has been surprising or interesting about looking at these larger data sets. Any other patterns that you've pulled out maybe more recently that have made you rethink what you initially thought about language development?
Let's see, the first, actually, maybe since we're talking about interactional style and style of learning, I had tended to be a little dismissive of people who said, hey, there are these really different styles of learning language for different kids. Um, because I'm kind of a simplifier. I'm a lumper rather than a splitter. And so I thought, oh, it's all just really differences, variation in the speed of learning. And so I was really surprised to see a very robust difference show up in our data set, which is that there are some kids who tend to be the earlier learners of language. We're talking like 1 to 2 year olds, maybe 2.5 year olds, for all of this. So this is all with kids who are young enough to be assessed using the CDI. But some of those kids who tend to be a little bit faster in language learning, be learning a little bit earlier, and they're much more referential in the old term for it. They learn more nouns. Their vocabulary is very skewed towards the names for things.
Hmm.
And in contrast, there tend to be this the other group of older kids, or maybe this is a spectrum, but along that spectrum, there are older kids who are learning a little slower, but who tend to be better at combining words relative to the number of words they actually know. So their sentences are more elaborated. And so you really do see this evidence for two styles across many different languages. So they're the kind of nounier, faster kids and the slower, kind of verbier, sentencier kids. Referential and expressive were the old terms for that. Expressive being the more sentence level, and referential being the more nouny. And the original study on that, I think it's from Catherine Nelson, and there were like 6 kids in it. And so I was I was ready for that not to be true, and it turned out to be very robust in our data that there are these different equilibria, and you can kind of now when I interact with kids, I think, oh yeah, okay, you really are a little bit more like that.
Wow, that's so interesting. I know you've studied a lot, or you've done a lot of research with pragmatics as well. And I was wondering if you had any thought about, for SLPs, how to go about, is it something that you teach, or is it something that more is about, that hangs together with all of these other things like phonology, semantics, syntax? Can you actually separate these things?
Yeah, that's a really great question, and I think I don't know the answer, unfortunately. I'll tell you, I wasn't even sure that pragmatics itself just hung together in all its different aspects. So we invoke the notion of pragmatics, right, of inference and context in all sorts of different aspects of kids and adults' language. Some of them are really super specific, like figuring out the meanings of words or making an inference about the meaning of a particular phrase, like what if I say some of the students passed the test, and you figure out from context that I mean not all of them did. Like those kinds of really like little linguistic pragmatic inferences are one case where we invoke pragmatics. And then another case we invoke it is like the general sense that you get of somebody's communicative goals and intentions based on all sorts of different things about the physical context and the way you're interacting with them socially and your history of discourse. Like there's both the teeny little pragmatics and the really big pragmatics, and I wasn't convinced that those were all the same thing. And we've done some work that suggests that they're at least correlated with each other within individuals.
Hmm.
So a scientist in Germany who used to be a postdoc in my lab, Manuel Bonn, has done some really nice work trying to measure pragmatic abilities with a really large battery of different tasks in preschoolers. So these are 3 to 5 year olds. And we find that the pragmatics tasks hang together quite nicely as a single factor. And they do differentiate from other things like vocabulary and executive function and so forth. And that felt, oh, okay, there's a construct, there's a there for early pragmatics and pragmatic inference. And now how does it relate to all of these other linguistic abilities? My guess, based on our WordBank work, is that it would, in a typically developing population, it would correlate very highly.
Hmm.
Not perfectly, but highly. And the reason for that is we do see correlations between very early communication skills like pointing, eye gaze, and so gesture, and later vocabulary. And more
Hmm.
generally, everything having to do with language in a typically developing population kind of correlates, right?
Hmm.
Like if you're better at babbling and you're better at early communication, you tend to have a bigger vocabulary. If you have a bigger vocabulary, you tend to have more grammar. And can you really see these things separate in clinical populations? The answer from the autism literature is probably yes.
Hmm.
Um, that you can see social communicative and pragmatic inference not travel with vocabulary and grammar. But I
Hmm.
don't know the extent of those things decoupling. And I'm not sure that we have the right study that's measured language ability and pragmatic ability across a wide enough range of kids and a wide enough range of ages.
Yeah, yeah, that is really interesting. Yeah, that someone who we're going to have on the podcast that you probably know as well, since she's married to Ted, is Ed Fedorenko, and I know that she's done some work on, brain. Like, there's no area in the brain that's doing, like semantics versus syntax. This all kind of wrapped up in the same network. Um, yeah, but you maybe this sort of suggests that there might be something a little bit more special about pragmatics.
Yeah, I think that's right. So I think one of the challenges of being a scientist studying a kid at a particular point is that what you see always is a snapshot of development. So you might have a kid that in principle had different pragmatic and linguistic abilities, let's say.
Mm,
But it's not that even if that were kind of at some time point true, like say there was an imaginary time zero when you could set those two parameters and you'd say they're good at this and not so good at that. Um, the reality of development is that everything gets intertwined. So if you're good at talking, you talk more, you have more interactions, you get more practice. And so one skill is going to drive the other,
mm,
or an impairment in one skill is going to drive an impairment in the other. So you get things getting wrapped up together that wouldn't necessarily have to be logically or biologically even, but because of developmental history, you can't necessarily
mm,
separate them. And when you take a cross-sectional slice of the population, you'll see that they co-vary.
mm,
So
mm.
this is one of the big analytic challenges, and one of the reasons why I think longitudinal methods can be quite powerful is because you can see development unfold, and you can see, in some cases, one ability driving the other over
Yeah.
time.
Hmm. I wonder, is this something that LLMs might have, some way to inform this conversation? I don't know much about the architecture or anything like that, but it seems at least that LLMs are kind of converging on appropriate use, at least like in a limited way. When I'm like conversing with an LLM, it feels like it understands my goals to some degree. And, that's ostensibly just from next token prediction. Is it possible like that you can get some level of pragmatics from just form and structure?
Yeah, I mean, I think it's quite challenging to draw conclusions from the big commercial frontier models like ChatGPT or Claude or Gemini. Like those models, they bake in the entire internet. And so
Hmm. Hmm.
not
Yeah.
only have they learned some pragmatics maybe, but they've also read a thousand papers on pragmatics. And there's so much baked into them and so many you know, tweaks to make them interact better for customers that it's really challenging to make inferences. The
Hmm.
place where I do think LLMs can be incredibly helpful, though, is as these small scale scientific artifacts where we can retrain not GPT-5, but GPT-2. We can train that on just kids' data. And that's the kind of thing that my lab and many others are doing to provide a little model system of acquisition. And that's super exciting because all of a sudden we can knock out stuff. Like there's a really cool study that came out last year where they retrained GPT-2 where they had knocked out one construction. Like there's a kind of an argument structure piece that they just took out of all the training data. And their question was, did this model still get some knowledge of argument structure even for this particular construction, even though it was missing that exact data in the input? And that's the kind of study that I think is just super exciting that you
Whoa.
can do with they're called baby LMs. Uh,
Uh,
you don't want ChatGPT. You can't see the guts of ChatGPT. You can't intervene on it in any way because it's just a giant thing in a data center somewhere that's completely proprietary. But a baby LM that you have on your own, um, maybe not your laptop, but your scientific computing facility, then you can do experiments on it that you could never do with a kid. You can't tell the parents, "Hey, you can." They won't let you. Never talk about zebras, and let's find out what the kid knows about zebras. Like that's a hard experiment to do.
yeah.
But or
Yeah.
or I mean even stuff that you would never do like be only anti-pragmatic to your kid, like never attend to the same thing that they're attending to. Like you'd never do that for a parent, but at some point we'll be able to do that with a language model and really try to understand the causal role that's played for the model in learning of that joint attention or of that construction.
Interesting. Sorry to cut you off. I'm just wondering about that study you mentioned. So you're saying that there's like some construction that it didn't get any input for at all. Did it end up learning that thing, or
Yes, it did. So this it goes into this longstanding debate in linguistics, which is eagles that have wings fly is a sentence, right? With an embedded clause like eagles that have wings fly. And then if you want to make it into a question, you say, do eagles that have wings fly? And there's this kind of moving, where does the do go? How do you move the clauses around? And so the way people have addressed that question is by, I think I got the example wrong, sorry, but
yeah,
they've
eagles that do have wings or something like
yeah
that, where the with verb movement?
Yeah,
This
exactly.
is,
Thank you. You see, I can never do this is why I'm a vocabulary person rather than a syntax person, because I can encode the examples. Um, so the question has been, can you learn that kind of verb movement in the absence of direct evidence about it? And so there have been this whole variety of studies where people in the past have tried to isolate those constructions and kind of failed. And this study really, it took out the whole family of constructions from the training corpus, retrained the model, and then it was able to do subject-aux inversion.
wow. Yeah, that's really cool. And that, I mean, that seems like it's a pretty obvious, the clear strike against the really hard-lined nativist approach, of, where you couldn't learn. I mean, I think LLMs in general, right? They've learned form pretty darn well from just input. So yeah, it seems like you can
Yeah.
do it.
It's a remarkable time to be a scientist studying these questions because we're really having to change our beliefs pretty extensively, I think, in some cases, because it is clear that, um, you know, the early hypothesis was language is not learnable without innate constraints, that you have to have some innate endowment, and that is not right, right? That
Mm,
that a fundamental hypothesis that got falsified. Now we
yeah.
can argue about the details, like how much data do you need, like how fast you learn when you don't have the innate constraints versus when you do. Like there's still plenty of room for scientific debate, but I think we've moved forward, which is really exciting.
Yeah, yeah, super exciting. So maybe we could talk a little bit about this. And one thing that you've discussed a lot, and one thing your lab is doing is this talking about this data gap that between LLMs and children. Can you maybe describe what this data gap is that you're referring to, and
Yeah,
how
yes.
we might be able to address it?
Great question. Yeah. So one big difference between ChatGPT and these baby LMs I'm talking about is just the sheer amount of data that's gone into them. And it's kind of hard to appreciate actually because the numbers are so enormous. We don't even know for GPT-5, like OpenAI will never tell us how much data went in to that model. And in fact, um, maybe there are a bunch of different models in there with different data, made up data. Who knows what's in there at this point? But for the largest models, we think that it's at least uh, in the trillions or possibly, tens of trillions of words of data. That's so much data, right? Um, 10 to the 13th
Yeah.
words of data. So 10 trillion words of data. Um, in contrast, my like kind of rough order of magnitude upper bound is that a baby could hear 1 million words a month. That would be a baby who's hearing tons of language. And so that 5-year-old's heard 60 million words of language, order of magnitude of data that a 5-year-old gets versus a language model. So whatever we think the 5-year-old knows about grammar, they've learned it or been born with it, and they have it with that amount of data. And so these baby LM simulations try to take that as a starting point, and they train models with a 10 million words or 100 million words, like something kind of human realistic, we back of the envelope numbers, and try to see what can emerge from training with that much smaller amount of data. And so the idea is by experimenting with smaller data sets, you can really get a sense of what you need to build in or what you need to do to the model to make it learn fast enough to simulate humans.
Got it. Yeah. And one thing that I found super interesting was it seemed like the evidence for curricularization, so like something like, starting with simpler sentences for kids, or, infant directed speech or motherese, is that developmental ordering of language did not seem to help at all the LLMs learn. Yeah, what do you think is behind that? And do you think it's maybe a disanalogy for humans?
Yeah, this is a great question. Again, I mean, it's really, and thank you for digging so deeply into these things
Yeah.
to prepare the questions. I think so. So here's the result. The result is that um, it doesn't make models learn better to train them on simpler speech to younger kids first, and then only later graduate to more complex speech. Why is that? Well, models learn from the general statistical distribution in the environment, and for any statistical learner of that type, you're kind of giving them the wrong distribution and then going to the right distribution, and that's not as good as just giving them the right distribution from the start. So that's the formal result. And the question is, what does that mean in terms of humans? Well, sometimes humans clearly learn from curriculum, and they do so really effectively, right? You can't teach a kid math by starting with calculus. That doesn't make any sense. You have to
Yeah.
curricularize. You have to start with numbers and addition and so forth. And that doing that ordering right is what a teacher does really carefully in setting up a class. That's the whole skill. So is language more like just statistical learning, or is it more like learning math? I think there's probably components of both, but to a certain extent, I think it actually is more like statistical learning. Like it wouldn't make sense to leave out sounds from language talking to a baby to be like, oh, let's use a subset of the sounds of English so that you get those down and then okay, we'll move on to, you know, speakers don't do that. They talk to babies and to small children about the things that they need to talk to them about, irrespective of which sounds are in or out. Same with constructions. So they may simplify a little bit in terms of vocabulary. They may make their sentences shorter. I mean, we know they do those things, but they also carry out their communicative tasks and they don't hold back aspects of language from babies. There's not like no questions because questions are syntactically more complex. So I think to a certain extent, language learning is a little bit more like just pure statistical learning and a little less like math. There may be
Mm.
aspects of curriculum, but much less so than for academic subjects.
That's so interesting. Yeah, someone else that I talked to recently was Dr. Jenny Safran, and she did the kind of the early work on statistical learning for infants, and it's really, really crazy to see what infants are getting from just strings of syllables and understanding the statistical probability of one syllable going to a next, and then from that determining things like word boundary. Yeah, it is such an interesting problem because it seems, just sort of intuitively that you want to start with simpler and tractable, easy to understand speech. When you're learning as an infant, just like if you're I was a guitar teacher a long time ago. I know we had the music connection as well. But yeah, you can't like start by learning a, Van Halen solo or something. You have to start with like row your boat or, and then, eventually you get to the more difficult stuff. I wonder if that has to do with all of the other sonic aspects of the sound that you have to sort of address in the brain. Like instead of just having a written token, you're kind of having to also form categories for sonic boundaries, I guess.
Yeah, yeah. Actually, let me riff off your music example because that's a really
Yeah.
great connection. So one thing to distinguish for kids, this is I'm making things up at this point, but I think
Yeah.
it's worth saying for kids, production and comprehension are two really different things, right? Getting the sounds out, one challenge, and then under the surface, understanding what somebody is communicating to you is another. And comprehension can be much easier, especially when the context supports understanding something complex. So I was always astonished when my kids were really little, like 18 months, how much I felt that they could understand about complex utterances, complex instructions, because the context constrained what I wanted, and there were a variety of other cues. And so they could get a lot of meaning out of something that felt way beyond what I would have expected. And so your example, I think, is fabulous. Like you would not tell a kid to start, you don't tell a guitar student to start with the Van Halen solo. You don't tell a kid to start by composing, metrical poetry or something like this also. But you also wouldn't want to tell your guitar student never listen to Van Halen, or maybe you would because you don't like Van Halen, but you wouldn't say like, don't listen to the Beatles, they're too hard for you. You'd say, listen to
Right.
whatever you want, listen to the music you love, learn it, internalize it. And hey, yeah, you may be playing Row Row Your Boat, but next up, like, you're setting the foundations to play the things you love. And by listening, you're learning about the style and the genre and the tonality of the music you love. So in comprehension, you can kind of get this statistical input that has the full richness. Even as in production, when you're practicing that skill, yeah, you do have to stage things out. And um, my son Jonah is now 6. He just today was his first day of first grade. He's doing great, but he's always had a little bit more trouble with speech motor stuff. He had some speech therapy last year for some sounds, and he had some kind of early intervention as well. And it's always struck me he's really like the times he gets frustrated is when he's trying to play the Van Halen solo, and he probably should have still been working on maybe not Row Row Your Boat, but at least like the Beatles or something, right? He's trying to get
Yeah.
out a really complicated thought about some engineering idea he had, but it's really challenging to explain the robot he wants to build in words when his words aren't coming as fast as he wants. And so I think what you said about music and skill learning is really right from the perspective of speech production.
Yeah, the production, your understanding could be like, way outstrip your ability to produce that stuff. Yeah. Um, I'm wondering, and we're sort of talking about these different aspects of how we can learn from LLMs and maybe that just the aspects of motor production or, other sensory modalities might play a role. I was wondering if you could talk a bit more about maybe your recent work with some of the like trying to do multimodal grounding and using Baby View and explain a little bit what that is and what your goals with that are.
Yeah, yeah, that's actually the other surprising thing I wanted to tell you about, so that's perfect. Uh,
Cool.
so kind of coming back to my whole origin story about this is I was really interested in doing computational models, but felt like we didn't have the data available to fit those models or to train those models. And so one really promising method for getting data about what kids experience and their language learning input and just generally their lives is this method that was developed by a bunch of folks in the developmental science community of putting cameras on their heads. Um, sounds obvious, but actually it's kind of hard to get a kid to wear a camera, and you have to figure out what camera and so forth. So there were a bunch of details that got hammered out, thanks to folks like Linda Smith and Chen Yu and Karen Adolph and a variety of other pioneers in this area. So uh, we've kind of now taken this to a more longitudinal setting where we're mailing cameras to families and asking them to put the cameras on their kids and record an hour every couple days and basically then just upload that to us for creating and sharing a data set of kids' early experiences captured from their perspective. That's called the Baby View data set. And one of the big insights from those data that I found very surprising, this is not, our data confirm this, but we're not the ones who came up with it originally. But we were talking about the Tomasello idea, right? This idea of the importance of triadic attention, of joint attention, of eye gaze, and like checking that you see that what I'm seeing, and that we're both attending to the same thing. And when you look at the headcam videos, that is there, but it's very rare. What we
Mhm.
see much more in headcam videos, and folks like Karen Adolph and Linda Smith and others have noted this as well, is we see the kids' hands and the adults' hands, and the hands are working together to show what the focus of attention is. Because often they're sitting there on the floor, or the adult's way up in the air or something, or the kid sitting in the parent's lap. The parent's eyes aren't visible, but the parent uses their hands to manipulate, to bring something into the child's field of view, or to manipulate it, to show it, point at it. And that focuses the joint attention very effectively. But really, the idea was that there were a lot of different sources for that joint attention and communication to get established, and not just eye gaze.
Wow. Okay, that's so cool. It's so interesting. And it sort of suggests too that we do have some a little bit more agency as therapists to kind of get this joint attention started at least by trying to bring things into the child's field of view. One strategy that some therapists use is, for example, like trying to like an object that the kid is really motivated by, if they're not like imitating yet, or if they're, less interested in joint attention, is to start to bring that object closer to the face, into the mouth, and things like that. And it seems to like anecdotally work, but it seems like, yeah, having also being able to just impinge on their on their field of view and start to talk is a it's cool that can be used as a way to help develop language.
Yeah, I mean, I've seen that, that therapeutic technique of like really trying to refocus attention on the face by co-varying it with the object of interest. And I do think that that seems powerful and important and should be probably one tool in the toolkit, especially because um, for kids on the spectrum, it's often a therapeutic goal to increase that social attention and engagement with social cues. the sharing attention with the hands is like it's another tool to put in the toolkit, right? It's another way to collaborate, and maybe it means that the kind of joint attention for language learning doesn't always have to be face-based. It doesn't, so that thing that's tough and challenging for the child doesn't always have to be the cue that reveals what we're talking about and helps learning move forward.
Yeah, that's fabulous. Yeah, awesome tip, and really cool that it's coming out of this new sort of innovative research. Yeah, is there anything now that you're kind of most excited about, or things that you're um, that you feel need to be studied more in the future?
Yeah, I mean, I think the thing that I'm really working hard on now is what we started to see in WordBank, which was that when you got data from many different countries and contexts and languages, you could really gain much more insight into what felt like it was, if not universal, then at least very consistent across these different contexts. And so getting outside of the single context where it's easier and most convenient to study really helped us build theories that felt more robust. And so both with the BabyView data set and with this new Levante data set that we're working on, which is with slightly older kids doing tasks and surveys. We're really working on cross-linguistic adaptation and measurement to try to get more diverse global samples contributing to the data sets that we distribute. And my hope with that is that the original dream of linguistics was to get these universal theories of language development. I think that is a very compelling dream. And maybe some things are universal, maybe they're not. But in order to evaluate those theories, you just have to be including a greater portion of the world's population across many, many different contexts in order to create responsible, scientifically valid theories. That's a critical need. And to do that, you can't just parachute in all these places. You actually have to create partnerships, set up working relationships with investigators, build capacity if necessary, like really create a community where people are studying child language and child experience and cognition, and contributing to data sets together. And that kind of global community building is really what we have tried to do with organizations like Levante and in the BabyView project with our kind of collaborative relationships, so that we've got when scientists come in and are trying to study pre-existing data sets, using their own approaches, those data sets are very representative of the world's population.
Yeah, that's really important. Any asks of the speech community here, that any of the speech therapists in the audience, anything that they can do to be a part if they're interested in furthering this cause?
Yeah, I think if folks are interested in any of the methods or data sets I described, please, yeah, first take a look at our website to see if you can find data that are useful for you. But then if you're interested in using our tools, please feel free to reach out to me. With respect to the CDI in particular, we do offer a web-based version of the CDI. This is kind of relatively low cost and hopefully useful in your clinical practices. And that creates kind of a virtuous cycle as folks use the CDI in their own work. Those data then, in a completely de-identified way, help us build better and more representative norms for the CDI. So you get better percentiles, you get better screening performance from the instrument. And so if you're interested in that, you can learn more about it. The site is called WebCDI.
Okay, I'll put that in the chat really quick. Is that through Brooks Publishing?
That's correct. Yeah, yeah. So
Okay,
they distribute
WebCDI.
a license that folks can purchase and use.
Awesome. And maybe just something else you're mentioning, if you can give one last, be a little speculative here. Do you have a universal theory of kind of language development, or I don't know. Yeah, what's your worldview right now
Yeah,
with
I
respect
mean,
to
I think
language?
it's a tough question, of course. So what I've written about is that I think that there are universals of process rather than universals of content. Like, I don't think that argument structure is necessarily universal. I mean, maybe it is, but that's not where I would start. What I'd start with is the learning processes that unfold over development and lead to relatively consistent outcomes despite very diverse and distinct experiences for kids. And those are processes like statistical learning, they're processes like pragmatic inference and social communication that together constrain the types of things that kids learn And then because they're learning in the communicative context with caregivers trying to create uh, um, both to manage the child's behavior and to create a good learning signal in some cases, that those interactional universals that some other folks like Steve Levinson have referred to also further constrain what gets learned. So um, the structure of learning and the learning mechanisms and processes being relatively universal can lead to language getting learned on a relatively consistent timeline and in relatively consistent ways, despite the really remarkable diversity of cultures and contexts and languages that kids are learning.
Amazing. Well, thank you so much, Dr. Frank. You're definitely an inspiration, and thank you for doing this work and revealing a part of this mystery of language. And any last remarks or conclusions?
Well, it's just a pleasure to chat with you. Thanks so much for doing this, and please feel free for anybody in the audience, anybody listening, to be in touch if you're interested in contributing to these projects or working with us.
Awesome. Make sure, just for all the SLPs in the audience, if your license requires CEUs, just go back to your dashboard on Speech Therapy PD and make sure to complete all the modules, including the quiz and the survey to complete the course. Thanks, everyone. And take care, stay curious. Hope to see you in the next episode. Maybe we could talk about bluegrass sometime in the future.
Oh, yeah, that's all another conversation.
Yeah,
we'll need another hour.
Another one. Yeah, definitely.
Okay.
All right. Thank you so much.
Take care.
Thank you, everyone. Take care.
Bye-bye.
Bye-bye.